All right, we're here to try some more examples of finding limits of sequences. So the first one is the square root of n squared plus 6n, all of that minus n. So there's a trick here when you see square roots and you see them being added and subtracted with things. And the trick is to multiply top and bottom by the conjugate. And what I mean by the conjugate is if you have an expression like a plus b, you multiply it by a minus b over a minus b. So if you have a plus b, you multiply it by a minus b. If you have a minus b, you multiply it by a plus b. The point of doing that is to take advantage of this difference of squares formula. Remember, a plus b times a minus b is equal to a squared minus b squared. So what that does is it kind of squares out the expressions for you, and that can often simplify a square root formula for you. So let's try that out with this example. We have the square root of n squared plus 6n minus n, and I want to multiply that by its conjugate, the square root of n squared plus 6n plus n. And to pay for that multiplication, I have to do some division by the same expression, the square root of n squared plus 6n plus n. And the point of that is that in the numerator, we get this a squared minus b squared expression. So we get the square root of n squared plus 6n squared, so that's just n squared plus 6n, the square root squared, minus n squared, and then that same denominator, n squared plus 6n plus n. And this simplifies nicely down to 6n over the square root of n squared plus 6n plus n. Now, we're not done yet with this because we still have something that's not so obvious. It's not so obvious what it does. We got 6n in the numerator, some square root stuff in the denominator. The key thing, remember, is to go through and look at the top and bottom and see what the biggest thing is in each, in both the numerator and the denominator. So on the top, I see the biggest thing here is the n. In the bottom, I see the square root of n squared. That's approximately n, even though there's a 6n next to it. The n squared is bigger than the 6n, so the square root of n squared is approximately n. And then, of course, we have an n in the denominator. So the biggest thing, top and bottom, would be n. And so what I want to do is divide top and bottom by n. And so that'll give me just 6 in the numerator, and then in the denominator, the square root of n squared plus 6n divided by n plus 1. And the square root of n squared plus 6n, I can write that as, well, I can make that a big square root, n squared plus 6n. Now, if I want to make this n part of the square root, I have to change it to n squared. And so that, in turn, becomes, if I split that up, 1 plus 6 over n. And so this whole thing becomes 6 over the square root of 1 plus 6 over n plus 1. And now it's in a format that's very conducive to letting n go to infinity. As n goes to infinity, the 6 over n just goes to 0. We get 6 over square root of 1, which is just 1, plus 1. So 6 over 2. And we get our answer that the sequence converges to 3. So there were a couple things, a couple clever ideas in that one. The first is noticing that we have a square root of something minus something. And the trick there is the trick to handling that is to multiply it by its conjugate. So we multiplied it by the same expression with a plus there. To pay for that multiplication, we had to do a division. And the point of multiplying by the conjugate is we can exploit this difference of squares formula. And so we get the square root of n squared plus 6n squared. That gets rid of the square root there. And then we get n squared. We get this difference of squares formula, which simplifies down into 6n. So that was kind of the first trick, was multiplying by the conjugate. The second trick was to look at the expression that we got and divide top and bottom by the biggest term that we saw, and to recognize that when we had the square root of n squared, that was really approximately n. So the biggest term in top and bottom was n. So we divide top and bottom by n, and then do some algebra to simplify it, and we finally get our answer.